Hello children, welcome back. We are now doing Telangana State Syllabus, 10th class, Mathematics, first chapter, Real Numbers. Before going to start with that topic, let us have a small discussion about a proverb. The proverb given here is, patience is a virtue. Virtue means what, children? It is the best moral quality that one should have, that always give a positive sense to you, a positive improvement in you. And what is virtue, children? Patience. What is meant by patience? Means waiting for something without getting hurriedly waiting for why I have not got this again and again, how long I should wait, this kind of feeling you should not have. You have done a job, wait for it. Definitely the result will come if you have done your job perfectly well. What you need, children? You need patience. Sometimes we do things, people will not accept it at that time. They may be in a mood of criticizing us. But after some days, you may feel at that time that I have done this for their sake only. They have not understand me. They did not understand me. They have mistaken me. And I don't want to be with them. That kind of feeling you should not have. You should wait. Let them understand. Give some time for them. They will understand your feelings and your bond will be much more stronger. So always think, have it in the mind, children, that patience should always be with you so that you will not have any hurdles in your life. Let us come back to our topic. I am doing Telangana State Syllabus, 10th class, Real Numbers. And in this Real Numbers, I am doing exercise 1.1. In the previous video, I have taught up to 3 problems. Check whether 6 to the power of n can end with a digit 0 for any natural number. Up to that I have taught. Now I wanted to go to fourth one. What is the fourth one? Explain why 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5. These all are why they are composite numbers he is asking. So first let us have a recollection of our number systems, and in that prime numbers and composite numbers. What are prime numbers, children? Prime numbers are those which have the factors as 1 and the number itself. So you will not get that number under any circumstances when you multiply any other 2 numbers. Those are prime numbers. What are composite numbers, children? Composite numbers are nothing but all those numbers which are not prime. That means for children, they have many factors in them. 1 and itself, of course, 1 and itself will be there for every number. Whatever big number you take, when you are writing its multiples or its factors, what you will write? 1 and that number itself is the first one. Then it goes on with the other tables we will talk about. So, apart from 1 and itself, some more factors also are available with it. Then only we will call it as a composite number. So, they have given us these values. This is first bit, this is second bit we can take. Now, in this, we need to find that it is it is a composite number. So let me take the first one. 7 into 11 into 13 plus 13. So children, this you can make it into 2 groups. This is one group, this is one group. In this, common is 13. So when I take out 13, I will get 7 into 11 plus this 13 is out, so I should take 1. Because when you open the bracket, 13 ones are 13. If you don't write 1, you don't get that 13. The place of 13 is occupied by 1. Because you have kept it a bracket, you have taken 13 as a common. So this means what? 13 into 77 plus 1. 13 into 78. So there are two factors. 13 into 78. Therefore, we will say that it is a composite number. What is the reason, children? Why is it a composite number? It has two factors here. So we'll say it is a composite number. So let us see the second bit also. 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5. This whole thing is one group. This is one group. In these two, 5 is common. So I am taking 5 out. 7 into 6 into 5 I have already taken. So I'll write 4 into 3 into 2 into 1 plus 1 I'll write. Why? Because I have taken 5 out. So this is nothing but 5 into, see children, 7 6 are 42. 42 into 4 3s are 12. I'll multiply this. 43 into 12. 12 3s are 36, 48, 49, 50, 51, 516. So I have multiplied 7 into 6 into 4 into 3. Now I need to multiply it by 2. 2 6 are 12, 2 1s are 2 1 3, 2 5s are 10. Okay, so you are going to get it as 7 into 6 into 4 into 3 into 2. Okay, so how much you are getting, children? 14, 7 6 are, sorry, here 7 6 are 42. I took 43, children. 7 6 are 42. 4 3s are 12. 12 2s are 24, 48, 50, 504. So 7 6 are 42, 4 3s are 12 into 2. 2 4s are 8, 0, 1, 0. 1, 0, 0, 8 you are getting this product. Plus you have 1. So how much, children? 5 into 1, 0, 0, 9. So when you are talking about this, as the value 5 into 1009, two factors are there. Therefore, what you will say? It is a composite number. So 7 6 are 42 into 4 3s are 12. I have multiplied. I got 504. So I should multiply it by 2. That is 1008. 1008 plus 1 is 1009. So you are getting product of two values. So product of two numbers is nothing but a composite one. So you are saying that this is also composite value. So in both the cases, the given numbers are nothing but the composite numbers. So I hope you have followed, children. Please copy. Now, we will go to the next problem. Now, what is the next problem? This is fifth one. How will you show that? How will you show that 17 into 11 into 2 plus 17 into 11 into 5 as a composite number? You have to explain it. Same problem like earlier. How will you show that it is a composite number? So what you have to do, children? In these two groups, what is common? You have got 17 as well as you have got 11. Both are common. So when you take it out, you will be getting 2 plus, here these two commons I have taken, 2 plus 5. So 17 into 11 into 7 you are getting. 17 into 11 into 7, these are three factors. Therefore, we will say that it is a composite number. Understood, children? This is a composite number. This is your fifth problem. I'll be doing the sixth one here, children. What is the sixth one? Which digit would occupy the units place of 6 to the power of 100? The problem goes like this. Which digit occupies 6 to the power of 100? Units place of 6 to the power of 100 they are saying. So suppose you have got 6 to the power of n is equal to 6 to the power of 100. They are asking. Now if you take n as 1, 6 to the power of 1 is 6, children. If you take n as 2, 6 square is nothing but 36. If you take n as 3, 6 cube, how much? 36 into 6. 6 6 are 36, 6 3 are 18, 21, 216. It goes on like this. So, whatever number you are taking, you are getting 6 only in the units place. Therefore, what you will say? Therefore, 6 to the power of 100 has 6 in units place. Because we have taken an example and we are considering 6 to the power of n is 6 to the power of 100. That means n value we are taking it as 100. Suppose you are substituting n with 1, 2, 3, 4 like that and you multiply and see. In any case you are getting in units place 6. The number will multiply, number will increase, but units place is not changing. It's only 6. So let it be 6 to the power of 100 or anything 6 to the power of 1000, any value let it be. You are going to get units place is always 6. That is the answer, children, for it. Please copy this. Now, we will be going to the next topic. Now, the next one is about rational numbers and their decimal expansion. We are going to talk about decimal expansion of rational numbers. Rational numbers means what, children? Q, no, you will represent rational numbers. And decimal expansion is the part that we are going to talk about. You have got certain problems, children, where considering you have certain terminating decimals they have given in the problem. Terminating decimals. These terminating decimals, you need to convert them into P by Q form. What are terminating decimals means, children? The decimals which when you write in P by Q form, a reminder, you are going to get 0. They are terminating. When you get remainder as 0, those decimals are called terminative decimals. So, let us see. Certain problems are given. First bit is 0.375. Now, what we will do is, you find out, you convert it into P by Q form and write the prime factorization of the denominator. First we will convert it into P by Q form and prime factors of the denominator. See, 0.375 can be written as 375 by 1000. Now let us simplify it. 5 7s are, 5 5s are, 5 2s are 0, 0. Again it goes. 5 1s are, 5 5s are, 5 4s are 0. Again 5 3s are, 5 8s are. What am I getting, children? 3 by 8. What is the prime factorization of 8? 2 4s are, 2 2s are. So you will be writing as 3 by 2 cube. This is the prime factorization that I have written for the denominator. What did I do, children? I have converted the given decimal into P by Q form and I have simplified it so that I'll get co-primes. I hope you know about what are co-primes. Co-primes won't have any number as common except 1. So that means what? When you simplify it, this you cannot cancel with any other number. So these are co-primes. Now, after writing them in the form of co-primes, you take the denominator and find the prime factorization. So this part I am going to do with the different problems given here. Second one is 1.04. 1.04 you can write it as 104 by 100. I hope you know, children, after decimal how many digits are there, that many zeros we are keeping. Here after decimal 3, so 3 zeros. Here 2, so we have kept 2 zeros. So let me simplify. 2 5s are 2 2s are 2 5s are 0 again. 2 2s are 2 6s are 2 25s are. Can I divide it further, children? It is not possible for me. So, I will be taking it as 26 by 25. So, this can also be written as 26 by 5 square because the denominator is 25, 5 into 5. So, I hope you have understood, children. Now, okay, write down this, then I will go to the next bit afterwards. Now, let us go to the next sum, that is the third bit. The third bit is 0.0875. So after decimal 4 digits you are having. So 875 by 10,000. Now simplify it. 5 ones are, 5 sevens are, 5 fives are, 5 twos are 0 0 0. Again 5 threes are, 5 fives are, 5 fours are 0 0. Again 5 sevens are, 5 eights are 0. 7 by 80. So what you are going to get with this, children? The value is 7 by 80. This can also be written as 7 by, take 80, 2 fours are 0, 2 20s are, 2 10s are, 2 5s are. So what are you getting? 2 to the power of 4 into 5. Okay, children, you got 2 to the power of 4 into 5. Now let us see the fourth one. What is the fourth one? 12.5. It can be written as 125 by 10 because after decimal only one digit. 5 twos are, 5 fives are, 5 twos are. So what are we getting? 25 by 2. It itself is the smallest one. You need not write the factors for it. So 25 by 2 you got it here. So this is for this problem, children. I'm separating so that it will be easy for you to copy it. So 25 by 2 you are getting. So all these terminating decimals, if you observe, children, what is the property that you are identifying? Either you see the first one, second one, third one, fourth one, all the denominators are containing either 2 or some power of 2 or power of 5, some power of 5, or you are having the both the powers, 2 to the power of n and 5 to the power of m. This property you should understand, children. Any terminating decimal, if you write it in P by Q form and find out the prime factors of the denominator, definitely the denominator contains the factors as either 2 or power of 2, 5 or power of 5, or sometimes 2 and 5 with different powers, sometimes same power, sometimes different powers. That is why one n and one m we have taken. Any other digit or number will not come in between them. You don't get any other number. Repeating, this is what you say, terminating decimals. This is the property of terminating decimals. All terminating decimals will be having the denominators as a product of 2s, or 2 to the power of some number, or 5 to the power of some number, or 2 and 5, 2 to the power of a number and 5 to the power of a number. Okay, children, this is the basic property which you should learn. Please copy it. Now, let us go to the next topic. What is the next topic given here, children? You have got a theorem. Theorem 1.3. This is, let x be a rational number. A rational number. It goes on like this. So let me read this and explain this, children. It's a lengthy one, so you can go through it in your textbook, page 11, I think it is. So you just go through it. I'm explaining. You open your book and listen to it and go through the words that are given. Let x be a rational number whose decimal form terminates. Means what is that number means? That is the number which is having terminating decimals. And then x can be represented in the form of p by q. I have done all the problems earlier like that only. X can be represented in the form of p by q, where p and q are co-primes. Be careful, children. P and Q should be co-primes. Means you have to simplify the given rational number in such a way that you cannot further divide it. Those two values are called, the numerator and denominators are called co-primes. They don't have any other common factor except 1. So when they are co-primes, then prime factorization of Q is the denominator, children. The prime factorization of Q is in the form of 2 to the power of n, 5 to the power of m, where n and m are non-negative integers. Keep it in mind. They are not always positive integers. This n and m, whatever I have written earlier, 2 to the power of n and 5 to the power of m, these two will be always positive. So in the theorem they have said only this. You can write they are 2 to the power of n, or 5 to the power of m, or 2 to the power of n, 5 to the power of m, where m and n are always positive. So this is your theorem, children. 1.3. Write the theorem in your notebook. Okay. Let me go to the next part. The next part here is, you have got do this sums in page. You have got to do this sums in page 11, children. These are about page 11, I think. Let me see. Yeah. In page 11, you have to do this. Do this in page 11. Write the following in P by Q form, where P and Q are co-primes. You have to write them in P by Q form. First bit is 15.265. How will you write this, children? 15265 by 1000. After decimal, 3 digits, 3 zeros. So 5 3s are 15. Usually many students, they do this mistake, children, here. What is the mistake that they do is, this 2 you cannot cancel by 5. So you need to take 2 and 6. Without keeping 0 here, you cannot take. So 5 3s are 15, 0, 5 5s are 25, 5 3s are 15, 5 2s are 10, 0, 0. You cannot further simplify it. 305053 by 200 is the P by Q form. Did they ask you to convert it into prime factorization? Okay, let us do it for the sake of our convenience. Let us do it. 200 is there. So what you will do, children? 200 means, that is 3053 by 200. can be written as 3053 by how much children? 200 sir. 2 5s are 2 25s are 5 5s are how much you are getting? 2 to the power of 4 into 5. So see, the theorem is acceptable here. It's a terminating decimal. So we are getting the denominator in the form of 2 to the power of 4 into 5. Next, second bit, 0.1255. How will you write? 1255 by, after 1, 2, 3, 4 zeros. So how much children? 10,000. So 5 twos are, 5 fives are, 5 ones are, 5 twos are 0, 0, 0. So what is the answer you are getting? 251 by 2000. That means 251 by, so do 2000 children. 2000, 2 ones are 0, 0, 0. 2 fives are 0, 0. 2 25s are 0. 5 fives are 0. 5 tens are 2 fives are. So how many 2s you are getting? 2 to the power of 1, 2, 3, 4 into 5s 1, 2, 3, 5 cube. So you see children, here and here combination of 2 and 5 only are there. So copy it children. I hope you have understood how I did this sum. Copy it. Now we will go to the third bit. Now the third bit here is third bit is 0.4. So you will write it as 4 by 10. 2 twos are 2 fives are 2 by 5. It itself they are co-prime. Since in the problem they said you have to write it as a co-primes. So 2 by 5 is the answer. Now fourth bit 23.34. So 2334 by 100. After decimal 2 digits. So you can cancel by 2. 2 ones are 2 ones are 2 six are 2 sevens are 2 fives are 0. You cannot do it further. So 1167 by 50. So find out the factors of 50. 2 25s are 5 5s are. So 1167, this is 7 children, by 2 into 5 square is the denominator for this fourth bit. Now when you go to the fifth bit, 1215.8. So how will you write? 12158 by 10, because after decimal 1 digit. So 2 fives are 2 6 are 1 cannot be cancelled. So 0, 2 sevens are 14, 2 nines are. So you are going to get it as 6079 by 5. These are the answers for this problems children. We have written the given decimal in P by Q form. Below you have got, you see, also, and also write the denominators in the form of 2 to the power of n and 5 to the power of m form. That is also being asked here. So what I did, I have taken the given decimal, I have converted it into P by Q form, and I have written them as co-primes by dividing it, and then for the denominator what are the prime factors I have taken. I hope you have followed children. Please copy. Now let us see what is the next topic that we can do. Next one, you have got another theorem children. Theorem 1.4. It is, let x is equal to p by q be a rational number. So let me read this also. It goes on like this. So let me read this statement, children. Let x be a rational number such that the prime factorizations of q is of the form 2 to the power of n and 5 to the power of m, where n and m are non-negative integers. Then x has decimal expansion which terminates. It gives the same meaning what we have done in the earlier theorem. In the earlier theorem, they have given decimals. They said that they are terminating decimals, so the denominator is in the form of 2 to the power of n and 5 to the power of m. Here they are saying that if a rational number is given in the form of p by q, where the denominator is in the form of 2 to the power of n and 5 to the power of m, then if you find the division of it, try to find out the solution, it will be definitely a terminating decimal. You'll be getting a terminating decimal for it. You have got, do this sums, children, here. Let me see about do these sums that you have got in this page 12, I think. Yes, page 12. Do these problems. So do this page 12. All do these sums are there in page 12. Write the denominators of the following rational numbers in 2 to the power of n and 5 to the power of m, from where n and m are non-negative integers, and then write them in their decimal form. So you have to write both, children. The first bit is given as 3 by 4. You can write 3 by 4 as 3 by 2 square. So you have written p by q form. Now you need to find out its decimal form. How will you find out the decimal form, children? You have to divide, no? Keep a point and 0. 4 sevens are 28, 2, 0, 4 fives are 20, 0. So it is nothing but 0.75. This is what he is asking. First, he is asking to find out the denominator in the form of 2 to the power of n and 5 to the power of m, and then you have to write the decimal form of it. Now, we will go to the next problem, that is 7 by 25. 7 by 25. You can write it as 7 by 25 means 5 square. So, you will have to do 7 divided by 25. So, you will take 25 here, 7 here. Keep a point and 0. 25 twos are how much, children? 50. 25 threes are 75. So, 2. So, keep a 0. 25 eights are 8 fives are 40, 8 2s are 16, 4, 20, 200. So, you are getting its value as 0.28. This is the value of this. I think the third bit is a little bit bigger one. I need space, so just copy it, children. First and second ones. Now, we will go to the third bit. What is the third bit? Third bit is 51 by 64. 51 by, take 64. 2 threes are, 2 twos are, 2 ones are, 2 sixes are, 2 eights are, 2 fours are, 2 twos are. So how much? 1, 2, 3, 4, 5, 6. 51 by 2 to the power of 6. 51 by 2 to the power of 6 is this answer. We have made a denominator in the form of 2 to the power of n, 5 to the power of m. No 5 here, only 2. Now you take this 51. It should be divided by 64. So it won't go, keep a 0. Then 64, that is a 6. 64 into, which one we will do, children? 6 7s are, usually we will take the 6 7s are 42. 6 8s are 48. So if you go for 8, 8 4s are 32. 8 6 are 48, 512. But it is bigger number. So you take 7. 7 4s are 28, 42, 44. So how much is, children? 2 here, 6 here. 62 you will be getting. Then you keep 0 here. If you keep a 0, now which table you will get, children? 62. 9s are, suppose you have taken 64 into 9. 9 4s are 36, 54, 57. Okay, so you have to take 9. 576. So how much you will be getting here? 4 here and here 4. Because 1 it goes there. So 4, 44. And then 0. So I'll continue here, children. You may not see if I do this. That is, okay, right from the beginning I'll do 510, 64, you have got 0.7448, then you have got 2 here, 6 here, 0, then 9s are 576, so you are getting 4 here, 4 here, 0. Now let me continue. 6 are 36. 6 7s are 42. But 7s are 448. So you go for 6. 6 4s are 24. 6 6 are 36. 38. So what is left behind here? 6 and 5. 56. So 56 and 0. So let us talk about 64 into 8 once again. 8 4s are 32. 8 6 are 48. 48 plus 3, 51. 9 are, how much you have got? 576. But this is more. So you take 8. 512. How much you got? 8 here, 5 here and 0. That means you have got this 9s are 576. No? You can take 9s are 576. You will be getting 4 here. He will be getting only 4 here. 4 and if you take 0. Okay, children. You are getting here 8 here and 5 minus 1, children, it is 4, not 5. Already 6 I have taken, 5 minus 8 is 4, 480. So 480 means what you will be getting? 9, and then you can go for 8. 64, 8, 6 are how much you have got? 64, 6 are 384 you got. So 480 we have to get 6 7 are 42. 6 8 jar. 8 jar means this is more. So how much for 7 jar you got? 4 4 8 you got. So you take this 7 jar. 4 4 8. So how much you are getting, children, here? Here 2. 6 minus 4 is 2. You keep one more 0. Here 7, no? 7 minus 4, how much, children? 3. 320. So if you take 5s, 5 4s are 20, 5 6 are 30 plus 2, 32. So you are getting remainder as 0. So what is the answer, children, here? 0.7968975. 7968975. So in case if you cannot say this part 480 minus 448. It is 320 and 320 0. So in case if you cannot see this part, you can see from here. Means after 512, the next part is this. Okay, children. In case if you cannot see this, you can write this. I hope you have understood this, children. Copy it. Now, we will go to the fourth one. What is the fourth bit? Fourth bit is 14 by 25. That means 14 by 5 square. Now, what you have to do? 14 by 5 square, 25 divided by 14.0. So, how much you will be getting, children? 25 and 140. You will be getting 2s are 3s are 75, 4s are 5 4s are 4. If you take 4 5s are 20, 8 to 100. So 5s are 125, 25 5s are 125. 6 are how much? 25 into 6. If you take 6 5s are 30, 6 2s are 12 3. So 6 are it is more. So we will take 5s are 5 5s are 25, 5 2s are 10 1 12. So how much you are getting here, children? 5. This is 1. So 15 keep 0. 7s are if you take 25, 7 5s are 35, 7 2s are 14, 3 17. It is more. So 6 are if you take 25, 6 are 6 5s are 30, 6 2s are 12, 3 15, 150. So I will take 6 are 150. This is 0. So what is the answer you are getting, children, here? 0.56 is the answer for it. So you are getting a terminating decimal with this fourth one. Now fifth one, 80 by 100. 80 by 100 is nothing but 80 divided by 100. 2 5s are 0, 2 25s are 5 5s are 2 square into 5 square is 80 by 2 square into 5 square. Now let me take this 100 and divide it by 80. So when you are taking this 100 and divide it by 80 divided by 100. So 80. Can you divide? No. So what you will have to do? You have to keep a decimal 0, 8 are 800, 0. So what is the answer, children? 0.8 is your answer. So these are 5 bits you are having in this. Do this. Up to this I wanted to take a class today, children, and the remaining I will be doing it in the next class. I hope you have followed me, children.